looking at things, and we're going to let David talk all about that. So David Linthicum.
Thank you. I went up the stairs that are marked with down arrows. I wonder if that's bad. I'm good? And there's the clicker. Okay. Is this the clicker? Oh. Did you take the clicker, Roger? I'll just say next slide till you guys find the clicker. This guy has a clicker. Thank you. Everybody's blaming everybody up here because someone ripped off the clicker. Let's talk about serverless computing, specifically, how it's going to change the cloud and also your job. So chances are, if you're here, you're either working in the cloud already, you're going to work in the cloud very soon, and your livelihood depends on you managing by magazine and updating your resume and absolutely getting certifications in the best and brightest technology so ensure that your paycheck is maximized. And I find that whenever I write and speak about those topics, about how cloud computing can enhance your career, those are absolutely the most clicked upon articles out there because everybody wants to be successful. But in order to be successful, you need to kind of understand, what it is and where it applies and, how to use it and put it in context. And one of the things that I focus on since I've been doing the cloud stuff for years and years and years is the practical application of this technology in areas where you should apply it and areas where you shouldn't. So I'm going to give you, kind of a brief understanding what serverless is. And by the way, it doesn't actually mean it doesn't use servers. Excuse me. And also how you can apply it in your own life. So things are kind of changing. I mean, I spoke at CloudEXPO a lot, and if you go back in time, maybe 10 years, 8 years, when we first started, talking serious about cloud, we thought cloud was going to be about operational cost savings and CapEx versus OpEx, things like that. And after hundreds and hundreds of cloud deployments and migrations and things that I'm involved with over time, I can tell you that that's really not true. Ultimately, cloud is about agility, your ability to speed the market, and what I call speed to fail, and you want to fail as quickly as you can, speed to change, speed to deploy. And we thought the operational cost savings, the OpEx versus CapEx stuff, which we love to say, and actually I put it in the first chapter of my book, I wish I could rip it out, was a secondary benefit. We knew agility was going to be the primary benefit, and speed and time to market was going to be a primary benefit, but we didn't know to what extent it was going to be. So here we are, and there's between 10 and 20% of our cloud workloads and data that exist in the public clouds, and some private clouds, but mostly public clouds. And what we're finding, at least in my customers and the surveys that I see, things like that, people come to the cloud for operational cost savings, the CapEx versus OpEx stuff, but they stay for the agility. And that's kind of a change in paradigm, what we talked about 8 years ago, 10 years ago when cloud computing first started. So the perceived value was cost savings, speed to deployment, speed to change, speed to fail, and then ultimately, this is the true value that we found. Operational cost savings, still there. We're still able to do things cheaper, not all the time, but most of the time. Speed to deployment, speed to change, speed to fail, basically the agility aspect of it, you can fail as quickly as you can, is typically where the value is going to be. So we're kind of upended. And the problem is, like back in the days of agility, and I kind of came from the SOA and EAI space into the cloud, that would kind of make people's eyes glaze over in terms of what it is and trying to explain a value that's very abstract in what they think. But they could put their money or put their understanding around operational cost savings. So I'm telling you that story to get to this story. So ultimately, we no longer we are needed to think about server resources when building or deploying applications. One of the dirty little secrets about public cloud computing was even though we didn't have to deal with hardware and software, we didn't have to configure it and install it into a rack within a data center, you still had to configure hardware and software that was virtual on the consoles, or whether you're using AWS or Google or Microsoft, whatever flavor of cloud that you're going to leverage. And this is always kind of perplexing to me because I looked at the platform as a service world, which people really don't care much about these days. But the cool thing about that is as I wrote applications, it would allocate the server resources that I needed for the instance that I needed and only charge me for the resources that it's able to leverage. With its data, something else. Basically, it all came together. So we're still in the business where we're dealing with public cloud providers like AWS in basically installing virtual rack computing. And also we're turning developers into hardware guys. Even though they don't see hardware, they still have to pick memory configurations, they still have to pick storage configurations, pick databases, things like that. And that's causing a bit of a distraction as we're moving into the public cloud. Specifically, when you look at DevOps and you look at the world of Agile, and we're doing things in continuous improvement and continuous design, continuous development, continuous testing, all these sorts of things. And so that should be why do we care? Sorry about that. No longer, ultimately, are we dealing with costs and scale. Traditional servers basically tearing up, and we have to reallocate and redeploy, deallocate the systems, reprovision them for the bigger servers that we're leveraging. We do so virtually, but instead of doing that, we're just kind of removing ourselves away from that. So that got a long way of saying that we're not dealing with the notion of servers anymore. Even though we're dealing with serverless, it's still dealing with servers. We just have back-end processes that are allocating the resources that you need to support what your functions are looking to do. So instead of you having to, if you're a developer, this drives you nuts, guess or even do some server sizing as to what you think you're going to need, chances are you're going to overshoot or undershoot what resources you're going to have, and you're going to have to reconfigure those damn things in a month or so once you start to scale up and it gets to different resources, things like that. So in my client base, we're over-allocating resources to the benefit of AWS or Microsoft or Google because they get paid more than they probably deserve. And we're under-allocating resources and we're killing our workloads because they're bumping their heads on server size limitations, storage limitations, things like that. So we're constantly trying to figure out how to allocate and reallocate these various systems so we can support the application workloads we're deploying to the cloud. So benefits of serverless computing, we don't have servers to manage anymore. And this kind of drove me nuts because I go like, we're supposed to live in the cloud computing world where things are going to be allocated for me and things are going to be taken care of and things are going to be on demand. And here we kind of remove ourselves from having no servers to manage. And this isn't new, by the way. We did this in the platform as a service world for years. And certainly in the software as a service world, even though that's more around a particular application workload, such as Salesforce.com. But in the infrastructure as a service, which is basically doing what we used to do within a data center and trying to mimic a data center, we'd allocate resources and bolt servers into a cloud. We're removing ourselves from having to do that. Smart. So also provides continuous scaling. One of the things that kept me awake and probably cost me and the companies I work for lots of money is the fact that they're going to bump their head when there's a spike in a particular process. And so I think that most people think this will automatically happen. There is some auto-scaling capabilities in some cloud-based systems. We can start allocating resources. But for the most part, I got to guess how much horsepower that my infrastructure as a service cloud, whether it's storage services, compute services, data services, things like that, needs to maintain in order for me to continuously scale to the thing that I'm going to make. And so the problem is people tell me where we're going to hit 1,000 hits a minute in probably a month. And so I'll set it up and size it for that. And sure enough, we hit it 5,000 hits a minute. Thing falls down, we have an outage for a time, we have to fix it, reallocate the systems, things like that, and we lose money in terms of customer confidence and us not scaling to the proper system size. But of course saying, well, Dave, you should have known or basically put in a fudge factor that we add additional resources. Well, that could be $1 million more in AWS fees that we have to pay over a year's time. And so it's very difficult to guess as to what that threshold is going to be. And then never pay for idle. And again, the problem is if I'm over provisioning my resources to support my particular workload, I'm paying for the idle nature of those resources. And we're trying to get into cloud computing to get away from that. One of the things that used to drive me nuts when I used to go into actual data centers and look at actual servers, all of them within the data center, and this is an average, were operating at 3%, 5% capacity. And all that idle time was basically being wasted. And the great thing about cloud computing is we can pull those resources and we can allocate those resources, and therefore all of these hardware systems and servers and storage systems and database servers and things like that, that are heating the planet up and causing, just huge amounts of electricity. And especially I live, in Northern Virginia, and that's like Data Center Alley. They're building up a new one every month or so. We got to get out of doing that, or else we're not going to get any further down the way. So we have to figure out how to use these things in more effective and efficient resources. So, why should you listen to me? You can make more money. You can go out and rewrite your resume and put serverless on it, put AWS Lambda on it, put Microsoft Functions on it, and lie your way into some good interviews. The good thing about the people interviewing you don't know serverless very well, so they can't tell if you're lying to them or not. So it's kind of a cool place to be. This is a big one. If you look at Lambda, which is AWS serverless solution, it's gone exponentially. And then if you look at the serverless, like the course I did on lynda.com, everybody's trying to figure out what this is and what it means to them in terms of their jobs and changing things like that. So if you're into cloud, containers changed your job. Certainly container clustering and orchestration managers like Kubernetes changed your job if you're into containers. But serverless is definitely going to change your job, whether you're in operations, whether you're a developer, whether you're an administrator, whether you're doing design work, things like that. This has become part of your life. That's just the way it's going to be. So what that translates to in ultimately and kind of plain English is now's the time, it's not too late by the way, that serverless cow hasn't left the barn, so to speak, to learn the stuff. So when this wave comes forward in a much more bigger way, very much like infrastructure as a service did in AWS, and very much like containers did, and very much like other things that we see, predictive analytics, IoT, all these other things. This is a nice little niche of a system to get knowledge of. Number one, because it's going to change the way in which you use the cloud, and it's going to change the way people develop applications in the cloud. Not everything systemically, and we'll get into where it fits and what doesn't, but it's going to have enough change where it's going to be impactful upon probably 90% of the existing IT shops that are leveraging public cloud computing. So get going with this. However, there's fitment issues, and one of the things that drives me nuts is you got a lot of vendors who stand up in front of clouds like this and talk about how serverless computing can solve everything, it can cure cancer, take care of your back pain, get you a good night's sleep, things like that. But the reality is there's fitment with everything. You can't take containers and apply them universally to every application workload out there. So serverless computing, the fit would be net new. In other words, new apps versus existing apps. It's very difficult to take a COBOL DB2 application and rewrite it as something that's serverless because you have to redo it as functions. You have to change the design of the application. We boil and decompose everything down to functions. So legacy is not a fit. Value on scaling is a fit. No value on scaling. I have a lot of workloads like that where there's 100 people using them today and there'll be 100 people using them in 2 years. So I don't have to worry about scaling. If they hire new people, they're going to let me know. Where I have scaling issues is when they attach the thing to the internet and they have no idea how many people are going to invoke this particular API their service. And more people invoke it or less people invoke it than estimated. And that's when you get into trouble. That's where serverless is a good fit. It's a good fit when you're service-oriented, and that means you know service-oriented architectures and decomposing everything down to microservices and APIs, coarse-grained services and fine-grained services, and it's not a fit if you're dealing with traditional kinds of applications, even, let's see, object-oriented, structured, that stuff's still out there, even procedural-oriented or proprietary 4GLs, and there's a lot of that stuff out there that just won't fit. So the way I figure it, it's probably less than 40% of the workloads out there that can be written to use serverless. It's 100% of the net new stuff, because obviously we haven't built it yet, so therefore we can build it with whatever language we want. But it's not a fit for everywhere, and if you're going to try to force fit it, you're going to get frustrated very quickly. Just remember I told you so. There's a lot, you can Google it out there and you'll find lots of different opinions on what's going to be a fit for serverless computing. And the reality is it's 40%, what it gets down to in the typical workloads that exist within my clients. And I bet if they did a survey and actually triaged the workloads out there that are moving into the cloud, we can turn 40% of them into serverless-based applications, and we can certainly turn all the net new stuff, but again, there's a cost in doing that. We have to look at the enabling technology to make sure it's a fit. So this is a use case, as is an old system, monolithic, server-intensive, difficult to update, maintain, add feature requests, things like that. Has a registration database, has an I will vote system, registration services, I will vote user, voter laws API that I guess it checks to do compliance auditing from itself. And then we turned it into a serverless architecture. And notice we go from something that's very simple and understandable to something that's very complex and could break. But this is how serverless is typically going to be used. Split out service functionality, voter registration process using serverless. We have a registration queue, registration function, which is a serverless function, registration server, and so basically the registration function is going to be serverless in nature. It's able to communicate with the registration database. The I will vote service has been rewritten. Registration API goes directly to the registration service, and this is how we typically would employ a service-based infrastructure. So this is typically going to fall down, but the trade-off is it's going to be simple to understand, and we can kind of understand it pretty easy. This has more parts, therefore it could be more brittle, but it's also going to have better scalability with the serverless function you see in the registration function on the right. So who's out there doing serverless? Well, we have the big three, AMG, Amazon, Microsoft, Google. AWS Lambda, one of the first on the market, largest user base, many use cases and workloads on the platform. One of the funny stories I have at AWS Lambda is I wrote a pretty detailed article on the limitations of AWS Lambda, I think this time last year. And I think they had kittens about it. And then everything in the article that I pointed out as a limitation, they fixed when they reInvent came around the next time. So I don't know if I did good or did bad, but they didn't like that article. But to AWS's credit, they stepped up and made it work. So now a lot of those limitations have been taken out. Definitely Gen 2 technology. It's ready to go. I use it lots of times. It works fine. The other one I use is Microsoft Azure Functions, tightly coupled with the Azure platform. Uses the Microsoft development model, which means .NET and C# and all that cool stuff that Microsoft developers like to play with. Works well for those on Azure or moving to Azure. You would think that would be the case, and that is the case. Leveraging data functions seems to be a very strong suit. The few times I've used it, it's worked, even though the applications I've tested it on were not intensive by nature. We'll start seeing those things, I'm sure, between now and next year. Then there's Google Cloud Functions, newest player, but very promising, scales well, has a good serverless function, third place, but catching up. And the funny thing about Google is they have a tendency to kind of be a fast follower in the cloud game, where you would think they would be a leader. Microsoft seems to follow Amazon into containers and now into serverless. They're a fast follower, but they seem to gain market because they have a larger share of developers. And then Google follows both. And so in place would be AWS by a long degree, Microsoft second place but catching up quickly, and then Google kind of a far third. And there's IBM in there, Oracle's in there, and a few other players. Alibaba. So working with AWS Lambda, you have an event source that basically has to be invoked for you to invoke a function. So it's the old event-driven, kind of programming. So I'm capturing either a time of day, someone's pressing a button, a message comes in that has a certain basic content, and then it evokes a function, such as Node, Python, C#, which in turn basically starts firing up the servers. and it happens automatically behind the scenes. So in other words, if I write my function, I don't care how many resources, including the data resources, the compute resources, is going to leverage. Basically, all the resources are going to be there to carry out the service of the function no matter what I write. And I'm removing myself or abstracting myself from having to deal with the notion of hardware servers. And no, it uses different languages, so you can port different languages into functions. However, you're going to have to do some redesign for most of the systems because we didn't write these workloads 10 years ago to adhere to the notion of service orientation or even the notion of functions. And so they have to be written to that particular paradigm. And all of them are the same in doing that. So Azure function, we have code config, we have language runtime, and Azure functions are serverless and event-driven, so they basically use the same kind of paradigm. And functions are called nano-services or microservices that can scale based on demand. So that guy and that guy pretty much have the same functions, and if they don't, the same features. And if they don't, they subsume each other's features. So if everybody's going after particular features in AWS Lambda, Microsoft is going to pick up on that and basically catch up, and then Google's going to do the same thing. And so the competition, always churning, always improving, and always asking the questions, and also listening to the users, which Microsoft and Amazon seem to be doing very well these days, leads to a pretty good product in both of those product instances. So, how do you build one of these guys? Did a little methodology, which is really, this is kind of iterative in nature, but you have the planning, which is something that developers seem to skip. You need to understand the features of Lambda, understand how to build the application, or whatever serverless system you're going to leverage. And so, planning the application allows you to leverage the serverless capabilities better. Since we're decomposing the application, whether it's net new or existing, down into sets of functions, your ability to do the planning and design is going to lead to the success of the application. So use best coding standards to build it, carry out the plan, and there should be continuous testing. You have to test the functions, deployment, and operations, including continuous operations and management. And so what I like to do is typically stick this thing, which looks very waterfall oriented, but into a DevOps process. And so in other words, we're not only doing serverless in terms of removing the developers and having to pick the infrastructure they're going to run in, which is where we run into issues and latency and complexity now, but we're putting this in some sort of an automated infrastructure, whether that's in the cloud and using AWS's DevOps stuff, using Microsoft DevOps stuff, or typically you're going to basically have to wrap your own between the cloud and the on-premise kind of things that are out there using best-of-breed DevOps technology. But the idea should be, planning should be continuous design. In other words, we're always changing and always improving the design. Building should be the coding operation and then automation from then on out. And so we're able to test basically through continuous testing, test for security, test for compliance, test for performance, component testing, pen testing, all that stuff should be set up. And then once we automatically leave that, if we set up the DevOps process, we get into deployment, and then we can continuously deploy as we need to iterate through it to basically create the best instance of the serverless software, and that goes directly into operations. And so there's no decoupling of the dev and the ops aspect, which is really the course of dev. However, I changed that kind of expectation for you in that this is really DevSecOps. So in other words, not only are we doing continuous development, continuous improvement, continuous integration, continuous everything doing the DevOps stuff, but we're also building security-based systems to ensure that we're not introducing vulnerabilities into the testing. And so we have security testing, we have penetration testing, we have performance testing, we have all these sorts of things that basically occur as part of the chain. And then that leads to automated operations, automated deployment, and then continuous feedback back to developers and back to the tools. So out of all that crazy stuff I just said, that means we're automating the crap out of everything to kind of remove the human beings from as much of the process as we can. So if we automate things, since machines are doing it, not humans, they're innately repeatable. They're ensuring their quality, they're ensuring the deployment, and we're going to be more successful with it. So you understand how they break down into Lambda functions. For example, if we're using Lambda, same thing goes with Microsoft Functions. We do plan, build, deploy, test, deploy, and operate. How that stuff basically maps the existing DevOps or emerging DevOps, typically infrastructures, into serverless-based computing. So that's it. I have 5 minutes for questions, probably do 2 or 3. Yeah?
You mentioned that there were some changes that needed to happen at the function level or the actual programming language level. What changes are those at a high level?
Yeah, you have to rewrite them as functions because they're typically the design of systems that were built 10 years ago weren't built using functions. They weren't even built using service orientation. They may be built using object-oriented development and Java, and even if they did a good job at that, they didn't break those inheritable classes down into functions, which are more kind of static or structured than we're used to. That's when you use a change. Yes? Yeah, I think they have to support serverless-based application storage and some serverless-based capabilities that exist within their MSP. They can either link with a public cloud to bring that capability in, or they're going to have to replicate that capability inside their organization. So MSPs I see as kind of the unsung heroes of the cloud computing world because they run everything that public clouds can't, and they're able to mix and match with cloud computing. So adopting the serverless thing would be what I would say if you're going to actually capture the market. One more. I'll be outside if you guys have any additional questions. I'm going to go, I have 2 more. I'll go one over here and one over here. Oh, sure.
My background's in Java. With the serverless technology, how does it work when you spin out that JVM? Isn't there like a time dependency to spin that out so it couldn't be instantaneous?
Yeah, he's talking about a time dependency and spinning out a JVM. I haven't run into that problem, but that doesn't mean it doesn't exist. So I guess I'm not really qualified to give you a particular answer to that as related to Java. But I've done Java on serverless. I haven't experienced that problem, at least from the team that I work with. So that's all I can tell you. But certainly, it could be a problem, so I'm not going to tell you it's not. Go over here.
Is there any way to avoid vendor lock-in in serverless?
Yeah, there is vendor lock-in in serverless companies because if you're going to be dependent on a particular serverless instance like Microsoft Functions, Google Functions, or Lambda, you're going to, in essence, lock in and walk down the aisle with that. And I should have brought that up in my presentation, so thank you very much for asking that question. That's going to be a trade-off in using the serverless stuff. And you're not going to hear that from the vendors. Well, I'm going to be outside if you have any additional questions. Other than that, turn it back to Roger. Thank you very much.
Good job.